I welcome you friends on the channel alltools.ru. Artem Lebedev is with you. Today, we are going to talk about these milling machines, or rather we are going to compare them. Namely, this is what we have a Makita RP2301FCX, and from the manufacturer DeWALT DW. Today we will compare them. Why did I choose these milling cutters for comparison? Because I believe that the milling cutter is compared mainly by several parameters. Yes, of course it's the cost. The cost of the Makita is a little more expensive. It is in the region of 25,000. The DeWALT is in the region of 22,000 rubles. It would seem that it was possible to compare it with this. It would have been possible, but I didn't, because the very first thing that stopped me in comparing these cutters is that here the milling cutter stroke is almost the same, almost equal. It is this indicator that is important for comparing milling cutters. And also, of course, this milling machine is inferior in power to all milling cutters, but also in various other characteristics. Therefore, I think that this milling cutter and this one are more suitable for comparison. The first thing I would like to start with is, of course, the configuration. Please note, they come with separate guides. The guides we have are DeWALT shorter, the Makita is longer. The parallel stops themselves are made here in approximately the same shape. The only thing is that DeWALT's is a little lighter, so much lighter and feels more dry. At the Makita, everything is already smoother in terms of micro-adjustment. The DeWALT has a screw made from below here, and the micro-tuning is configured like this. As I have already said, it's a little bit dry, but by the way, I like this DeWALT dryness in some way. Somehow it's all more clearly. What I would like to draw attention to right here is that DeWALT has these brass lambs made here. Brass does not eat up the aluminum base as much as steel, so we will twist, screw, unscrew much more cycles, so to speak, much longer. What's in the layout here? Here the micro-adjustment is made a little more convenient. Here we have a clip on the side. We release and adjust. We will return to setting up parallel stops a little later, when we try to work with them. And now let's move on. At Makita, we have a collet for 12 and 2 bushings. One bushing for 8, the second for 6. Further, that here we also have a Makita with such a nozzle for a vacuum cleaner and a protective screen. We can install either a flap when we work without a vacuum cleaner, or here is a nozzle for working directly with a vacuum cleaner. Then we have a key to unscrew here to tighten the collet, and here is such a screw. I'll talk about it a little later. This is a very interesting thing for us, or rather, very necessary. Not exactly the screw, but the function it performs. At DeWALT's, we have a collet of 12 millimeters. It is exactly 12 millimeters, not 12 and 7. I measured with a bar, and there is a marking here that we have 12. Then we have this kind of nozzle for a vacuum cleaner, and this nozzle is made a little bit in a different form. Here we have a vertical exit, and the Makita has a horizontal one. There is also an additional element here that holds the hose. We'll install it all on the milling machine, and try to work. I'm going to show you everything, and we'll compare who has poly removal works better. Further, what we have here is a copy bushing like this. I'm going to show it closer now, and tell you about it in more detail. Mounting of the copy sleeve, and a key for unscrewing the collet. And now let's talk about the cutters. According to the technical characteristics, the similarity we have is that here both the milling cutter has a smooth start, speed adjustment. The turns are a little different here, I'll tell you a little later. Further, we have here by similarity, is that they are equipped with electronic speed stabilization, under load of both milling cutters. The difference between these cutters is precisely in electronics. DeWALT, we have 2000 watts, Makita 2100 watts. And the speed of the spindle rotation is also different here. The DeWALT has firm 8000 to 20,000 revolutions per minute, and the Makita already has firm 9,000 to 22,000 revolutions per minute. There is another difference in terms of electronics. This is that we have a backlight in the layout, but there is none in the DeWALT. And now let's take a closer look at these milling cutters, and I'll tell you the differences and similarities in terms of ergonomics, usability, and various little things. Let's start right away with the main part of the milling cutter, namely the immersion base. Here, as you can see, everything is working smoothly and neatly now. I want to draw attention to the layout. The springs are much weaker than on the neckline. On the neckline, in order to lower it to the end, you have to make a decent effort. I apologize for the rudeness, of course, pay attention to the Makita. Well, there was a little jump here too, but still. Maximum immersion stroke on the layout. Please note, I measure from the base of the sole to the base on the milling cutter. Here we have 75.5 millimeters. Please note that the guides are lowered completely. Now DeWALT. Its working stroke is 79 millimeters. Almost 79 millimeters. Here too, lowering occurs to the very end of the base. Pay attention to how it goes down. Now for one handle, now for the other. It's already a little tighter in this part. Now DeWALT. Everything is smooth and neat, not pressed. Here, well, a little bit is pressed, then there is a snack. At first, this is exactly what we can omit with two hands, we can't do it with one hand. I thought it was done on purpose. After all, as it is written in the operating instructions, we are obliged to work with a milling cutter during submersible work, holding it with two hands. Therefore, I thought that all of a sudden, well, maybe it was done specifically for safety. But it's more like attributing advantages to him, which are not, because during operation with vibration, we will still have it going down, and yet this is his jam of snacking on the guides. Of course, I started to figure out why DeWALT works like that, and Makita works like that, and figured it out. I'm going to show you all this now, but before that, let's look at the backlash. So, the backlash on the DeWALT. There is a backlash, it is not so significant, but it is still present. Now let's look at the backlash in the clamped position. There is a little backlash, but only when I press very hard. Of course, when milling in a clamped position, we do not press so hard. I think that in a clamped position, this will not affect our work. Now Makita. Backlash is present, but much less pronounced than on DeWALT. Now in the clamped position. In the clamped position, there is practically no backlash, but if you press harder, there is a little bit in this part. But it is very, very insignificant. The backlash on these cutters is still present. On the layout it is less significant. On the neckline, it is a little bigger and more rigid, with such a certain characteristic sound. On the layout here, everything is smoother and softer, so to speak. The backlash in the clamped position is more likely to be felt by users who have little experience with the milling cutter, who still incorrectly distribute the load on the milling handles. Experienced users, of course, will not feel this backlash, you can say at all. So, because of what happens snacking, and a less smooth course, as a result of this on the devolution. Let's take it apart now, or rather take it off the rails, and I'll show you everything. And Makita too. Please note that the spring on the layout is longer than on the DeWALT, but on the DeWALT, it is more so tight. Due to the fact that the Makita weighs more than 1 kilogram, namely, it weighs 6 kilograms, 100 grams. Audi Volta 5 kilograms, 100 grams. The difference is exactly 1 kilogram. Here, look, the guide is a little smaller, on the layout a little shorter. And the snacking is due to the fact that here we have a solid brass insert. Here it is, as you can see from this side, and from this one equally. Here we see our clip. On the layout here, we have a small sleeve in this part. This part acts as a clamp, because here we still have a pretty big backlash. This part is just freely moving. And the second part is made here in this form. Please note that this bushing is made on ball bearings, that is, here we have already done everything exactly in such a way that the guide rides on the balls. This part has been taken out separately. I'm going to show you how it's more convenient than on the layout. Yes, the nut itself is more convenient here. Here we can press and lift, that is. It is not necessary to twist it for a long time. But the most basic thing. Yes, by the way, the Makita does not have such a button here. Here we will need to twist it to the moment we need. But that's not the point. For example, we turn the milling cutter over. By the way, there are special 4 legs here. We install it for the installation of a milling cutter, for the installation of a copying sleeve, etc. For anything. Here we have set, and here is a moment like this happening. We rest this limiter right on the table. Here we can freely omit. Again, here, well, as for me, the wire is badly broken both there and there. This, so to speak, is a moment in terms of ergonomics of working with a milling cutter. Now, as I have already shown, this revolver stop here, it is quite convenient, and with a micro adjustment. Here it is made exactly the same way. So, at the bottom we have almost everything. Now I'm going to show you how to install a parallel stop and a copy sleeve. And by the way, about the bushing. Here we have it stamped, but this part is turned out, that is, here we have it calibrated, as well as the position in the milling cutter. And by the way, the reverse side is wrong, you will not be able to insert it. There is a hole not quite in the center here. We turn it over, or rather we turn it around, and the holes fall into place right exactly in the center. Here we have calibration, and here the internal landing size is also calibrated. And that's it. And we get it centered. On the layout, the bushing is installed as follows. We need to pull this lever here. I have a little bit of a sleeve from another milling cutter, but also from Makita. Here inside, the landing diameter is fully calibrated. Pull the lever and install. Everything is installed tightly, there are no backlashes. The inner diameter is 74 mm per DeWALT. The diameter on the layout is 68 mm. Now let's get to the top part. Let's start from the beginning with this zone, so to speak, the zone of setting the depth of immersion. Nadia Volta, and on the layout, as you have already noticed, everything is through the looking glass, just like with cars. Left and right hand drive. Here we have this setting on the right, here on the left. Let's get to know them better now. On DeWALT, we have this slider with a lens. To be honest, I relate to the lens, well, let's say, to myself. It is not very convenient for me, because, of course, there is an additional marking on the reverse side, too, like this. In order for us to connect these two markers, match them together. But still, it's not very convenient for me. I love to see firsthand. The DeWALT setting is as follows. We let go of this handle and turn this wheel. There is also a micro adjustment with the help of turning this little twist. As you can see, there is no indication here, and there is no landmark of any kind. But again, about the indication and landmarks. Yes, this is convenient, but still we rely on the readings we received on trial material, rather than directly trusting the figures entirely. We're trying anyway. Now how it happens on the layout. There is also a peephole. Here we have 0 only in one place, not in the center, namely at the bottom. Now the setup itself. Here, micro adjustment takes place along the entire guide. That is, by turning the handle. There is also a quick setup here. We release this nut, press it, and we can freely lower and raise it. On both milling cutters, this is all done quite reliably, nothing will slip through, that is, we can still configure it pretty well. And it will keep the setting. The next thing I would like to talk about is the milling cutter buttons. On the neckline, it is located on the left side. Here we have a fully fixed button. Here we have the up position on, the down position off. Now on the layout. Here we have it made in the form of a trigger, and, as for me, it's more convenient or safe, but maybe it's a matter of habit, because I'm more used to the trigger. First of all, we can't press it until we press this button on top. Click and we can already work. Again, on my 3612C milling cutter, this acts as fuses. Here, this button performs the function of fuses, and also, if we press it a little further away, it performs the role of fixing the button. In order to release the fixation, we just need to press the button. That's it. Handles in terms of ergonomics at the Makita, they are so much more pot-bellied, but rubberized and as if poured into the hand. DeWALTs are so much more slippery, they are purely plastic, there is no rubberization here, they are so empty, so to speak. But they are thin. Well, for someone, skinny handles are more comfortable than such more weighty and massive ones. The next important point is that here we have a quick change of brushes on the milling machine. There is no quick change of brushes on DeWALT, we need to remove the top cover and dig around there. I'll show you that later. The next thing that I liked more about Makita here is the setting of the spindle speed. Here the button is slightly recessed inside, and it is more fixed, that is, it moves with such some effort. On the stage here, the button is somehow even a little crooked, but it's like this, more squishy and so all. Now let's compare the wires in length. The Makita we have is so much thicker, the one is quite thinner, but they are both rubberized and quite high quality. By the way, both cutters are not made in the People's Republic of China, although this is also not bad. Factory China is a good production, it's pretty good. The most important thing is that it is not clandestine and not a fake. This milling cutter is made in Italy, and this milling cutter is made in Japan. That is, we have a pure-blooded Japanese. Let's now look at the length of the wires. So, DeWALT is about 80 centimeters shorter than Makita. And to be more precise, DeWALT has 3 meters and 30 centimeters of wire, and Makita has 4 meters. I personally tried it all on myself. Now the following, in my opinion, is a very important difference, namely, it concerns the installation of the milling cutter in the table. Here, in order to make, so to speak, a micro-lift, we will need to remove this nut and install a special device here, which is purchased separately. On the layout here, we have done everything a little differently. And so let's say, a micro-lift is already built into the milling cutter. Pay attention to this part here. This bushing, we have a thread there. This happens as follows. We install the milling cutter in the table, and here, as you can see, there is a small hole. We also make it in the table. Next, what happens? We have a screw like this in the kit. We insert it and fix it in this sleeve. We twist it. We don't need to climb under the table and twist anything. We have everything on top here. Insert the screwdriver. A screwdriver, anything. And we begin to twist. The more we twist, respectively, the higher our milling cutter rises. And before we work, let me tell you about the collet. The collet has a regular shape, as you can see, a smooth cone, everything freely enters. And the milling cutter is clamped along the entire length of the collet. It is exactly the same here, although it is shorter. There are some collets, they are not quite right. There is a cone on top right away. It is inserted and fixes almost only up. The lower part fixes the weakness. Here, everything is fine with us. Now let's install them on the milling cutter. Please note, as I have already said, there is such a rather large step of carving on the layout. On the DeWALT, it is much smaller. And there are more carvings on the layout. By the way, the spindle lock has 2 positions here, both on the layout and on the devolution. Let me install the milling cutter now, since it is impossible to tighten the collet without a milling cutter at all, in fact. So, now let's look at the spindle lock. Quite a strong lock. The layout is 4612, and she has never let me down. But here, please note, there is no additional turnkey space, specifically to hold the spindle itself. Here we only have a button. Nadia Volta, we have, so to speak, a choice. I found a small moment on DeWALT, which, so to speak, is in the process of working. Well, I don't know, maybe again I'm used to the layout, but I think it will affect. Here, pay attention. We have the back side of the milling cutter, and here we have nothing stopping us from tightening the female. Both tighten and loosen it. By the way, don't pay attention to this long distance. Yes, of course, in theory we should insert the cutter a little deeper. In general, the marking here should be in the shape of the letter K. But here we must have a bearing. And a clamping sleeve that holds this bearing. Now it is missing, I took it off. And here, as you can see, the thickening is small, it will not go into the collet. Therefore, there is such a seemingly large distance here, but there is nothing terrible about it. What didn't I like a little bit here? And I didn't like the fact that the button is located from this part. Personally, it is more convenient for me to twist the collet when I press the button on top. And when we have this part, for example, set up for something. Yes, it's clear that when we change the milling cutter, we have all the settings go wrong, but still. For example, I have it set up, and the milling cutter is already set up approximately as needed. We tighten the cutter, and this part does not interfere with us a little. In fact, it may be possible to roll up to it. But it is still possible to accidentally damage this part. Therefore, we will have to remove it before tightening the cutter. The following situation, again with this part. Here, when we relax the cutter, we can hit the thread, which is also not good. If we do this with an additional key, this problem goes away by itself. In other words, we work with the help of the second key, and everything is fine here. Basically, I have told you all of their similarities and differences. If suddenly I have not told you enough, write of course in the comments. I will definitely tell you there are take into account in the following reviews, because well, maybe something of course I missed. And now let's try to work with them, put parallel stops, see how they are configured, what is backlash, not backlash, and try how they will cope with dust, more precisely, how the dust removal system will work. Let's go. We will be milling MDF. I think it is more correct for comparison. Yes, from anywhere, milling cutters, screw, it doesn't matter. The material we have is quite dense and homogeneous. In this situation, it is better to remove the guides away, so that we can freely clamp the material. And the guides do not interfere with us here. First, let's set the milling depth. We rest the cutter, clamp it. We rest against this pin, fix it, set it to 0. Let's go. Now we know 0. We have 16 millimeters of material. We need to mill 8 millimeters. Now let's set this parameter. First with a rough setup. Then we will adjust it so that it is exactly 8 millimeters. Now let's adjust the milling depth horizontally. Now we have a milling cutter that bites into the material quite strongly. We make micro-tuning. We will set the milling depth to exactly 10 millimeters. So, in this way we have exposed exactly 10 millimeters, and now the milling cutter is ready to work. So, we went through the first groove with you, and here it turns out that we milled 9 millimeters into the depth here, and 9.5 millimeters in this direction. But still close to this distance, but it is absolutely necessary before we mill to check on some sample, and already adjust with the help of these numbers here. Now let's go through the same part, right on the entire milling cutter, and see how the milling cutter pulls it out. The milling cutter is quite large. Of course, it's better to walk. If we need such a great depth, we need to walk for several passes. Now I'm doing this in one pass just to understand how overloaded the milling machine will be. I set the revs to the maximum. Let's go. In this way, the Makita milling cutter showed itself. To be honest, the revs could have been slightly reduced in order to have more reserve for constant electronics, but still, the milling cutter coped perfectly and showed itself worthily. Now let's check with the same cutter what DeWALT will show us. So, we have now clamped the milling cutter in the same way and set it to 0. And now let's try the setup here. By the way, that's the plus of this system. When we twist in the layout, the screw has an easier stroke, and we can safely twist just that very millimeter a little. Here they rested and clamped down. We set 0 with the lens and set the same 8 millimeters depth. So, they tightened up. Now the parallel emphasis. So, the first pass to the specified depth. By the way, pay attention, there is no engine brake. How is it there? There is no such abrupt stop. Very, by the way, a convenient thing. Some people are afraid that the milling cutter is twitching, but the milling cutter stops pretty quickly, and it's safe and convenient. We can remove the milling cutter from the work area faster. Pay attention to the milling cutter. Why am I stopping now? With some snacking after all, but it goes down. When I turn on the milling cutter, there is still a micro vibration, and it is released much more smoothly. So, everything is pretty smooth. Let's see what we got. 8.2 approximately. That is, we are closer to the correct size. In other words, it is that system that works better in terms of adjusting to the desired size. Now the depth that we have exposed with a parallel focus. Here we have 9.2. In principle, they also almost hit. Now let's go through the whole milling cutter. By the way, a very comfortable respirator, in my opinion a Tremovsky one. Generally cool. So, both cutters coped with this task quite well, and it seemed to me that he did it quite a bit more quickly, although he had a little less power. And while the dust settles, I'll tell you some points about fixing the buttons. These button fixations have both a plus and a minus. The downside is what? Well, let's say you forgot the button in the on position. When we plug the milling cutter into the network, it starts up. Accordingly, so is Makita. That is, there is no protection against accidental startup here, both in one and in the second. And, by the way, pay attention. If we start it by simply turning on the brake, the engine does not work for us. What is the advantage of such buttons? And the plus here is not only that we do not need to constantly hold the button, plus, it is when we install these cutters in the table. I know from my own experience that we use a milling cutter in the table and always connect a vacuum cleaner. So, you can use a vacuum cleaner, or rather, many people use a vacuum cleaner as a power button. We leave the button in the on position, already in the table. When we have it installed, insert the cord into the vacuum cleaner. And when we have the vacuum cleaner in the off position, the milling cutter is turned off. We turn the vacuum cleaner to the on position. We turn on both the vacuum cleaner and the milling cutter. Now install the nozzle for the vacuum cleaner. Here we have a small hole now for small cutters. If we have a large milling cutter, we remove the cover and, please, use such a milling cutter. I really liked setting the milling depth. And by the way, pay attention, we do it right like this. So that's it, we have already set 0. It's really cool done. And by the way, we're going to need scotch now, not with DeWALT, but with Makita. I have a thick hose right now, and it certainly doesn't go through this ring. Here is a special ring for additional fixation of the hose, so that it does not drag anywhere here, or vice versa. In an inverted form, it also fixes a little. We don't need him right now. The original adapter for the branch pipe from Bosch gauze 1225 pi L, great for DeWALT. The dust collector copes perfectly. Now there would be a lot of dust here. We have already paid attention to this milling. We milled quite a lot, deeply, and there was just a little bit of dust left, just a little bit, just a little bit. In terms of installing the Makita pipe at a height of, here we need to unscrew just one small screw. As you can see, the Europeans, the Japanese, are a little conflicted in this regard. I still don't understand how they didn't give the Nobel Prize to the one who invented scotch. It's a miracle scotch. That's the kind of thing we got. Yes, in terms of working with a vacuum cleaner, everything is fine with Makita, and by the way, he didn't even leave anything at all. After all, there is a little wider entrance here, and therefore, I think that the result of working with a vacuum cleaner is a little better. This video is coming to an end, and what I want to say in the end. I didn't show two things, well, maybe even more, but exactly the ones that I planned to show were noisy. I will definitely show it at idle. Yes, it is clear that different cutters, different materials emit different noise, but still the noise at idle is also important. Especially when we embed these cutters in the table, because there it works in stationary mode and makes noise. You can say at idle for a long time. Let's look at the idling first, and then summarize the results, and I'll show the disassembly. Also in the same limit works. Therefore, they are about the same in terms of noise. Well, what do I want to say in the end? Yes, there is a certain moment with the guides here, which is exactly with this snack, but I think that this snack should disappear over time. I'll explain why. Now there are all these sharp corners everywhere, and over time, it seems to me that I have already worked. And it has already become less felt, this snacking. Maybe it will disappear, maybe not, I don't know, but snacking in some moments made me tense. Here, the lowering of the milling cutter is just pleasing. It's just so smooth that they want to work and work. You feel it especially, that's the difference. You see, now I can lower it with one handle. That's it, the milling machine is already starting to get used. In terms of dust removal, milling power and depth, I think these parameters are quite enough, even for tapping locks into doors. Because the depth is quite large. Here we have pretty solid guides in general. We can even slightly unscrew them, just another 5 millimeters. We can add this straight. It will be straight safe, so to speak. I do not advise further. There will already be a big backlash, and in general a backlash with long cutters is a dangerous thing, and not very good. According to the DeWALT settings, it struck me right about this setting. At first I thought that they had done something here, but they had twisted it, but they had stuffed it. And now, when I worked with it, I saw how really convenient it is, and I have, for example, on the layout on my 3612, there is a similar adjustment. And here it is, in fact, there is such a joint that we rest and adjust it. We don't feel these micro, so to speak, adjustments, we just can't feel them, and we have to do more probes. Here we have everything much clearer in terms of settings. By the way, in terms of these pipes here for Volta, and on the layout, pay attention here. Everything is up here. And I probably wouldn't even take it off, because, well, there's not much sticking out anywhere and it doesn't get in the way. Here we will need to throw the pipe, then put a protective screen. Yes, it happens quickly here, but still it doesn't get in the way here, and here it needs to be done. Therefore, in principle, you can forgive him, this milling cutter, for taking too long there. In general, the overall impression of the DeWALT and the dip remains only positive. The milling cutters work great, both one and the second. And this review has come to an end. Put your thumbs up, be sure to subscribe to the channel All Tools. Do not forget about the bell, write a whole bunch of comments under the video. This is necessary so that I can answer and just chat with you. His bearing is quite large. Here you can see the numbers, made in Italy. Our brushes change quite problematic. Here, in order to pull it out, I unscrewed this part, but it does not go further. It needs to be picked up and clamped. Another bonus for those who watch to the end. Never lubricate what does not need to be lubricated, what the manufacturer does not recommend to lubricate. If you lubricate any of these parts that are not recommended to lubricate, dust will immediately stick there. And this mechanism will become unusable very, very quickly. Namely bearings, guides, bushings, and other miscellaneous things. See you soon.